Thermodynamics is a branch of physics that studies the relationships between heat, work, temperature, and energy. It focuses on the behavior of systems, particularly in relation to equilibrium and energy transfer. Key concepts include the laws of thermodynamics, thermodynamic potentials, and various processes like isothermal and adiabatic changes. We will also explore spontaneous processes, Gibbs free energy, and enthalpy changes. Let's dive into each of these important concepts and understand how they play a critical role in physics.
Thermodynamics is concerned with energy changes in physical and chemical transformations. Thermodynamics, however, gives no information on the rates of these processes or underlying mechanisms involved. A part of the universe under thermodynamic investigation is called the system. All other parts of the universe outside the system, such as cylinder, room, are surroundings. A property which depends on the amount of matter present in a system is called an extensive property. Examples include mass, volume, internal energy, heat capacity, and number of moles. A property which is independent of the amount of matter in a system is called an intensive property. Examples include pressure, temperature, surface tension, viscosity, melting point, boiling point, and specific heat. State functions define the state of a system and are independent of the path taken to reach that state. A system is in thermodynamic equilibrium when its state functions do not vary with time.
A transition from one equilibrium state to another is called a process. They are of different types. Isothermal process. The temperature of the system remains constant. Heat flows between system and surroundings to maintain this. In this process, the internal energy of the system remains constant, meaning both delta T and delta U equal 0. Isobaric process. Here, the pressure remains constant during transformation, typically in open containers at atmospheric pressure. Isochoric process. In this process, the volume of the system remains constant during transformation. A thermodynamically reversible process occurs in such a way that the driving force is slightly greater than the opposing force. Reversible process features. The driving and opposing forces differ infinitesimally, reversible by slight changes. A reversible process proceeds infinitely slowly in an infinite number of steps,